students. So in our today's session, we will solve long answer type questions of NCERT example for inverse trigonometric function. So this would be example number 12. We have to prove tan inverse of under root 1 plus x square plus under root 1 minus x square upon under root 1 plus x square minus under root 1 minus x square is equals to pi by 4 plus half of cos inverse of x square. So in this problem we will apply two formula of cos 2 theta, that is one is 2 cos square theta minus 1 and another is 1 minus 2 sin square theta. So first of all let us assume this x square to be equals to cos theta. Now in this place tan inverse of under root 1 plus cos theta plus under root 1 minus cos theta upon under root 1 plus cos theta minus under root 1 minus cos theta. So in place of this 2 cos square theta minus 1, when cos 2 theta is given, suppose this cos theta is given, then it will be 2 cos square theta by 2 minus 1, and taking 1 on this right hand side, so 2 cos square theta by 2 will be cos theta plus 1. So here under root 1 plus cos theta is given, so it can be written like 2 cos square theta by 2 plus, in place of 1 minus cos theta, similarly this 2 sin square theta by 2 will come, and similarly for the denominator part. Now cancelling this 2 and under root of square will be, that is cos 2 theta and sin 2 theta. So cos theta by 2 and sin theta by 2. So it will be tan inverse of cos theta by 2 plus sin theta by 2 upon cos theta by 2 minus sin theta by 2. On dividing this numerator as well as denominator with cos theta by 2 term, we will get it in the form of tan, that is tan inverse of 1 plus sin theta by 2 upon cos theta by 2 upon 1 minus sin theta by 2 upon cos theta by 2. So since we want this to be in the form of tan inverse of tan, hence we are doing this. So finally we will get the new term, which is tan inverse of tan, that is 1 plus tan theta by 2 upon 1 minus tan theta by 2. Now in place of 1 we can write tan pi by 4. So it will be tan inverse of tan pi by 4 plus tan theta by 2 upon 1 minus, here tan theta by 2 into 1, we can assume 1 here. So it will be tan pi by 4 into tan theta by 2. So now applying this formula of tan, that is tan pi by 4 plus theta by 2, will have this equation. So ultimately we will get tan inverse of tan of pi by 4 plus theta by 2. Now applying this property, that is f inverse of f of x is equals to x. So our final value will be pi by 4 plus theta by 2. And since we assume x square is equals to cos theta, hence our theta will equals to cos inverse of x square and theta by 2 will be 1 half of cos inverse of x square. So placing this theta by 2 over here, we will get our final required value, which is our solution, cos inverse of x square. Hence this will be our right hand side. Next is example number 13. In this we have to find the value of cos inverse of 3 by 5 of cos x plus 4 by 5 of sin x. Here x is given, that is it belongs to minus 3 pi by 4 to pi by 4. So if we plot this x on unit circle, we will get it. It is minus 3 pi by 4 will be in this clockwise direction. So here will be our minus 3 pi by 4 and here will be pi by 4. So in between this our x value lies. Now first of all, what we are trying to do, we will try to do to convert this in the form of cos alpha minus beta. So after that we could apply this formula, that is cos alpha minus beta is cos alpha into cos beta plus sin alpha into sin beta. So for this let us assume 3 by 5 to be equals to cos alpha, and based on this if we plot it on the right angle triangle, so our cos alpha will be 3 by 5, so this would be 5. So cos alpha is 3 by 5 and sin alpha would be 4 by 5. Now we will write it here, cos inverse of cos alpha into cos x plus sin alpha into sin x. Now it is in the form, that is cos alpha minus beta. So we will write cos inverse of cos alpha minus beta. Now when can we write that is cos inverse of cos x is equals to x? See, when this x belongs to 0 to pi or minus pi to 0 or pi to 2 pi and so on. So when this value of x lies in these intervals, only then we can write cos inverse of cos x is equals to x. So when we assume this cos alpha is equals to 3 by 5, in general condition we assume that alpha belongs to 0 to pi by 2. So now we want to know that whether this alpha minus beta lies in these intervals, so that we can write cos inverse of cos x is equals to x. So here it will be x. So our x is given, that is x is minus 3 pi by 4, x less than pi by 4, and our alpha is given, that is 0 less than alpha less than pi by 2. So when we subtract this alpha, this second equation from this first equation, then we will find an interval, and we have to verify that whether this interval belongs to is the subset of these mentioned intervals. So now we will try to do this. So suppose I am multiplying this whole equation with minus. So when we are multiplying this equation with minus, this signs will get reversed. So ultimately our solution will be 3 pi by 4. Suppose we are multiplying this with minus 1, then minus 3 pi by 4, and this sign will get reversed. So ultimately we can write it like minus pi by 4 less than equals to minus x less than equals to 3 pi by 4. Now we subtract this equation, adding this equation with this one. So finally we will get minus pi by 4 less than equals to alpha minus x less than equals to 3 pi by 4 plus pi by 2 will be our 5 pi by 4. Hence our cos, that is cos inverse of cos alpha minus x, and alpha minus x belongs to minus pi by 4 to 5 pi by 4. Hence, if x belongs to this interval, and alpha minus x will be from minus pi by 4, that is minus pi by 4 will be here, and our 5 pi by 4 will be here. When the rotation is anti-clockwise, then our 5 pi by 4 will be here. So finally our alpha minus x will belong to this minus pi by 4 and 5 pi by 4, and since this interval belongs to this pi to 2 pi, hence in this condition we can write for cos function cos inverse of cos alpha minus x to be alpha minus x, and in place of alpha we can put the value of 10. So suppose alpha is given, that is 10 will be our alpha will be 10 inverse of 4 by 3. Hence finally we can write 10 inverse 4 by 3 minus x. So this is our required solution.